8,000 years before the Common Era, the world looked nothing like it does today. In Mesoamerica, the region stretching from central Mexico through Central America, small bands of humans moved constantly across the landscape. These weren't primitive people stumbling through existence. They were skilled hunters, expert trackers, and botanical geniuses who understood their environment in ways we've only begun to appreciate. Archaeological evidence from sites like Guilanaquit's Cave in Oaxaca shows these groups traveled in bands of 25 to 50 people, following seasonal patterns that had been refined over thousands of years. During wet seasons, they'd camp near rivers and lakes. During dry periods, they moved to higher elevations where different plants and animals thrived. Their diet was remarkably diverse. Remains from trash heaps, what archaeologists call middens, revealed they consumed over 200 different plant species, dozens of animal species, and aquatic resources. They ate deer, rabbits, peccaries, turkeys, fish, turtles, and insects. They collected wild avocados, chili peppers, amaranth, chia seeds, and countless fruits and nuts. This lifestyle had its limits. Population density remained low, perhaps one person per square mile. Women could only have children every 4 years or so because infants needed to be carried during constant movement. Life expectancy hovered around 30 to 35 years, and perhaps most significantly, cultural development progressed slowly because knowledge died with each generation, never accumulating the way it would once people stayed in one place.
The transformation began with an unremarkable grass, Teosinte, its name derived from the Nahuatl word Teosintli, meaning grain of the gods, grew wild throughout the Balsas River Valley in southern Mexico. To modern eyes, it looks nothing like corn. The entire cob was barely 2 to 3 inches long, with only 5 to 12 kernels, each encased in a stone-hard shell that would crack your teeth if you tried to bite it. Yet someone noticed this grass. Perhaps during a particularly harsh dry season when other foods ran scarce. Perhaps a curious child, or an innovative elder willing to try something others dismissed. What we know from genetic analysis is that around 9,000 years ago, people in the Balsas River Valley began paying special attention to Teosinte. They didn't invent agriculture overnight. The earliest evidence suggests they simply protected patches of wild Teosinte, maybe clearing competing plants around them. They harvested the seeds, probably roasting them to crack hard shells, grinding them into flour, or boiling them into porridge. Then came the breakthrough. They noticed that some Teosinte plants had slightly larger seeds than others. Some had seeds that were slightly easier to remove from their shells. And crucially, they recognized that if they planted seeds from these better plants, the offspring inherited these desirable traits. This was artificial selection, the same process that would later give us poodles from wolves and beefsteak tomatoes from berries. But these early farmers discovered it independently, thousands of years before anyone understood genetics or heredity. By 8000 BCE, archaeological sites show clear evidence of human-modified Teosinte. The cobs are larger, the kernels more numerous. Most tellingly, the seeds don't naturally scatter in the wind anymore, a change that made the plant dependent on humans for reproduction, but made harvesting dramatically more efficient. This was no longer just Teosinte. It was becoming maize, becoming corn.
While maize was being transformed in the Balsas Valley, another revolution was happening with beans. Wild beans, species of Phaseolus, grew as vines throughout Mesoamerica's diverse ecosystems. Like Teosinte, wild beans were small, toxic if not properly prepared, and not particularly productive. Archaeological evidence from Coxsatlan Cave in the Tehuacan Valley reveals that by 8000 BCE, people were actively selecting and planting specific bean varieties. The earliest domesticated beans show up in the archaeological record around 7000 BCE, but the process clearly began earlier. What's remarkable is that beans complemented maize perfectly, and not just agriculturally, though we'll get to that, but nutritionally. Maize is low in lysine and tryptophan,
essential amino acids humans need. Beans are rich in these amino acids, but low in maize, which maize provide abundantly. Together, they create a complete protein that rivals meat in nutritional value. Did ancient Mesoamericans understand amino acids in complementary proteins? Of course not. But they understood that people who ate beans and maize together were healthier, stronger, and had more children who survived to adulthood. Over generations, this knowledge became embedded in cuisine and culture. The agricultural partnership went deeper. Beans are legumes, and legumes have a remarkable ability. They host bacteria in their roots that convert atmospheric nitrogen into forms plants can use. Nitrogen is the most common limiting nutrient in agriculture. Before chemical fertilizers, nitrogen-fixing crops were the only way to maintain soil fertility over years of farming. Plant maize alone in the same field for multiple seasons, and yields collapse. Plant maize with beans, and the beans replenish the nitrogen that maize consumes. It's a sustainable partnership that allowed Mesoamerican agriculture to thrive for millennia without the soil exhaustion that plagued early farmers in other regions.
The third sister, squash, has the longest domestication history of all. Genetic and archaeological evidence suggests squash was being deliberately cultivated in Mesoamerica as early as 10,000 years ago, making it one of the oldest domesticated plants in the Americas. Wild squash species, Cucurbita pepo, Cucurbita moscata, and Cucurbita argiosperma, produced small, bitter fruits, but they also produced large, nutritious seeds and, crucially, huge leaves that created ground cover. Ancient farmers recognized that these broad leaves had multiple benefits. They shaded the soil, reducing water evaporation. They suppressed weeds that would compete with crops, and they created a microclimate that retained moisture. By 8000 BCE, domesticated squash varieties were widespread across Mesoamerica. Archaeological remains from Gila Nukit's cave show that squash seeds had doubled in size from their wild ancestors, and the fruit walls had become thinner and less bitter, easier to eat. The Three Sisters system, maize, beans, and squash planted together, created a synergistic agricultural ecosystem. Maize stalks grew tall, providing structural support for bean vines to climb. This eliminated the need for stakes or trellises. Beans fixed nitrogen in the soil, feeding all three crops. Squash spread across the ground, creating living mulch that conserved moisture and prevented weed growth. But the system offered more than agricultural efficiency. It created dietary completeness. Maize provided carbohydrates and some protein. Beans added protein and essential amino acids. Squash contributed vitamins A and C, fiber, and healthy fats from the seeds. Together, these three crops could sustain a population indefinitely. And they did, for over 10,000 years.
Agriculture didn't immediately create cities. The transition from mobile hunter-gatherers to settled farmers took millennia and happened in stages. But by 8000 BCE, we see clear evidence of this transformation beginning. The earliest semi-permanent settlements in Mesoamerica appear around this time. These weren't cities or even villages in the modern sense. They were seasonal camps where groups returned year after year, eventually building more substantial structures and staying longer each season. Sites like San Jose Mogote in Oaxaca and Real Alto on the Ecuadorian coast show this transition. The earliest structures are still simple, posts supporting thatched roofs, wattle and daub walls, or even just windbreaks. But they're being built in the same locations repeatedly, creating the first permanent footprints of human habitation. Why did agriculture enable settlement? The answer is partly about food storage. Wild foods, game meat, foraged plants, spoil quickly. You can't accumulate them. But dried maize, beans stored in sealed pots, and preserved squash can last months or even years. For the first time, people could stay in one place through seasons when fresh food was unavailable. Population dynamics changed dramatically. Settled women could have children every 2 to 3 years instead of every 4. Infant mortality likely remained high, but more children survived to adulthood. Archaeological evidence from skeletal remains shows population growth accelerating wherever agriculture took hold. But settlement also brought new challenges. Living in the same place year-round meant dealing with human waste, attracting vermin, and facing new disease dynamics as population density increased. Early settlements show evidence of intestinal parasites and diseases that rarely affected mobile hunter-gatherers. The social structure evolved too. Hunter-gatherer bands typically operated on relatively egalitarian principles. Leadership was temporary and task-specific. But settled agricultural communities needed to coordinate planting and harvesting, manage stored food, and resolve disputes over land and resources. We begin seeing evidence of social differentiation. Some burials contain more grave goods than others, suggesting emerging social hierarchies.
The third sister, squash, has the longest domestication history of all. Genetic and archaeological evidence suggests squash was being deliberately cultivated in Mesoamerica as early as 10,000 years ago, making it one of the oldest domesticated plants in the Americas. Wild squash species, Cucurbita pepo, Cucurbita moscata, and Cucurbita argiosperma, produced small, bitter fruits, but they also produced large, nutritious seeds and, crucially, huge leaves that created ground cover. Ancient farmers recognized that these broad leaves had multiple benefits. They shaded the soil, reducing water evaporation. They suppressed weeds that would compete with crops. And they created a microclimate that retained moisture. By 8000 BCE, domesticated squash varieties were widespread across Mesoamerica. Archaeological remains from Gila Nukit's cave show that squash seeds had doubled in size from their wild ancestors, and the fruit walls had become thinner and less bitter, easier to eat. The Three Sisters system, maize, beans, and squash, planted together, created a synergistic agricultural ecosystem. Maize stalks grew tall, providing structural support for bean vines to climb. This eliminated the need for stakes or trellises. Beans fixed nitrogen in the soil, feeding all three crops. Squash spread across the ground, creating living mulch that conserved moisture and prevented weed growth. But the system offered more than agricultural efficiency. It created dietary completeness. Maize provided carbohydrates and some protein. Beans added protein and essential amino acids. Squash contributed vitamins A and C, fiber, and healthy fats from the seeds. Together, these three crops could sustain a population indefinitely. And they did, for over 10,000 years. Agriculture didn't just change where people lived, it transformed what they could create. Settlement enabled technological innovation impossible for mobile populations. Pottery is the perfect example. Ceramic vessels are fragile and heavy, worthless to nomadic peoples who needed portable containers.
But for settled farmers, pottery was revolutionary. It allowed for better food storage, protecting grain from moisture and pests. It enabled new cooking methods, boiling and stewing, that made tough foods tender and improved nutrition by breaking down plant toxins. The earliest Mesoamerican pottery dates to around 2500 BCE in most areas. But the technology that would enable it, clay working, fire control, understanding of materials, was developing during this earlier agricultural period. Sites from 8000 BCE show increasingly sophisticated use of fire, construction of permanent hearths, and experimentation with clay for building materials. Agricultural tools evolved rapidly. The digging stick, a simple pointed pole for making planting holes, became more specialized. Agricultural tools evolved rapidly. The digging stick, a simple pointed pole for making planting holes, became more specialized. Archaeological sites show these tools being fire-hardened, weighted with stones and fitted with handles for better leverage. Ground stone tools for processing grain became more common and more sophisticated. Textile technology advanced. Wild cotton was already being used, but settled populations could invest time in fiber processing and weaving. Evidence from tri-cave sites preserves fragments of early textiles, simple twined fabrics, and eventually true weaving. These required hours of work to produce and would have been impossible luxuries for mobile populations. Perhaps most significantly, settlement enabled knowledge accumulation. An elder who spent 60 years perfecting maize selection techniques could teach children and grandchildren who could build on that knowledge. Technical innovations in one generation could be refined in the next. This acceleration of cultural evolution is visible in the archaeological record. The pace of change speeds up dramatically once populations settle. As agriculture spread across Mesoamerica, the landscape itself transformed. This was humanity's first large-scale environmental engineering, and its effects remain visible today in pollen records, soil composition, and even the distribution of plant species. Pollen core samples from lake sediments tell a remarkable story. Around 8000 BCE, in areas where agriculture was being practiced, we see dramatic shifts in vegetation. Forest pollen declines, grass pollen increases. Most tellingly, maize pollen appears in layers where it had never existed before, and in concentrations far higher than any wild grass could produce. Early farmers used slash and burn, agriculture a technique called swidden or milpa in Mesoamerica. They would select a forest plot, cut down smaller trees and vegetation, allow it to dry, then burn it. The ash provided nutrients for crops, and the cleared land received full sunlight. They'd farm that plot for 2 to 3 years, then allow it to lie fallow for 7 to 10 years while they cleared new areas. This wasn't as destructive as it sounds. In the low population densities of 8000 BCE, the forest had ample time to regenerate. In fact, this created a mosaic landscape. Patches of active farmland, recently abandoned fields being colonized by pioneer species, and mature forest. This diversity likely supported more wildlife than either pure forest or pure farmland. But humans were beginning to shape ecosystems to their preferences. Useful trees like avocado, cacao, and certain palms were protected or deliberately planted even in wild areas. Over generations, the forests near settlements became enriched with human useful species, creating what archaeologists now call anthropogenic forests, wild ecosystems that are actually partially human-designed. Water management began during this period. Simple irrigation channels directed seasonal stream flow to agricultural plots. Terracing on hillsides reduced erosion and created flat planting areas. These early experiments with water control would eventually lead to the complex hydraulic systems of later Mesoamerican civilizations.
The shift to agriculture had profound effects on human health, some positive, some unexpectedly negative. Skeletal remains from this transitional period reveal both the benefits and costs of the agricultural revolution. On the positive side, food security improved dramatically. Agricultural populations suffered fewer seasonal starvation periods. Children received more consistent nutrition, which shows up in skeletal growth patterns. Agricultural populations show less evidence of growth interruption, which appears in bones as Harris lines, caused by periods of severe nutritional stress. The Three Sisters diet provided remarkable nutritional completeness. Together, maize, beans, and squash supplied all essential amino acids, complex carbohydrates, fiber, vitamins A, B, and C, and important minerals like iron and calcium. This plant-based diet was actually more balanced than the diet of many hunter-gatherers, who often had feast or famine cycles, with periods of protein abundance followed by carbohydrate scarcity. But agriculture also introduced new health problems. Dental health declined sharply. Hunter-gatherers typically had excellent teeth. Hard, fibrous wild foods kept them clean. But agricultural diets high in processed grain caused more cavities. Skeletal remains from early agricultural sites show significantly more dental caries and abscesses than remains of hunter-gatherers from the same regions. Average height decreased. This seems paradoxical. Weren't agricultural people better fed? The answer is complicated. While agricultural populations had more reliable food, they also had larger populations and more mouths to feed. During periods of drought or crop failure, agricultural people were vulnerable in ways hunter-gatherers weren't. Hunter-gatherers could move to areas with different resources. Farmers were tied to their fields. Physical stress increased in some ways. The repetitive labor of grinding grain shows up in skeletal wear patterns, arthritis in finger joints, wear on knee cartilage. Carrying heavy loads, water, firewood, harvested crops left marks on hip and spine bones. Agriculture was hard physical work, often harder than hunting and gathering. New diseases emerged. Living in permanent settlements with accumulated waste attracted rats and other disease vectors. Higher population density allowed contagious diseases to spread more easily. Domesticated animals, dogs were already present, would eventually bring their own diseases into contact with humans. Agriculture didn't just change what people ate and where they lived, it fundamentally transformed human social organization and culture. Property concepts emerged. Hunter-gatherers had personal possessions, but land ownership made no sense when your group moved constantly. But farmers invested labor in clearing land, building irrigation, improving soil. These improvements had lasting value, creating the first incentives for claiming specific territories. Archaeological evidence shows early farming settlements gradually spacing themselves out, suggesting developing concepts of territorial boundaries. Labor specialization became possible. In hunter-gatherer societies, nearly everyone hunted or gathered, but agricultural surplus meant some people could specialize.
Evidence from 8,000 BCE sites is limited, but we see the beginnings. Some individuals spending more time making tools, others processing hides, suggesting the earliest division of labor beyond basic age and gender roles. Wealth inequality appeared. Burials from agricultural settlements show increasing variation in grave goods. Some individuals were buried with elaborate offerings, ground stone tools, shell jewelry, special pottery. Others had simple burials with few or no goods. This variation is much less pronounced in hunter-gatherer burials from earlier periods, suggesting agriculture-enabled or required social hierarchy. Gender roles likely shifted, though evidence is indirect. In most documented hunter-gatherer societies, women gather plant foods and men hunt, but both contribute roughly equally to calories consumed. In agricultural societies, women typically did most crop processing, grinding grain, preparing food, maintaining gardens, while men did more heavy field work. This may have shifted the balance of economic contribution and social power. Ritual and religion evolved. Settled populations could build permanent ritual structures. They could store sacred objects too fragile or heavy for nomadic transport. They could develop more complex ritual calendars tied to agricultural cycles, planting ceremonies, harvest festivals, prayers for rain. The earliest evidence of monumental architecture in Mesoamerica appears several thousand years later, but the conceptual foundation that sacred spaces should be permanent and maintained began with agricultural settlement. Time perception changed. Hunter-gatherers lived in cyclical time, seasonal rounds repeating endlessly. But farmers needed to plan across seasons, save seed for next year, think in terms of future harvests. This required new cognitive frameworks for thinking about time and causality. They also needed to track astronomical cycles precisely, when exactly to plant, when to harvest. This drove development of calendrical systems that would become extraordinarily sophisticated and later Mesoamerican civilizations. The agricultural developments of 8,000 BCE seem modest: small, cleared fields, semi-permanent camps, crops that were still being refined from their wild ancestors. But these innovations laid the foundation for everything that followed. From these agricultural beginnings would emerge, over millennia, some of humanity's most sophisticated civilizations. The Olmec, often called Mesoamerica's mother culture, would arise around 1500 BCE, with massive stone heads, complex religious systems, and long-distance trade networks, all supported by maize agriculture. The Maya would build towering pyramids, develop the most sophisticated writing system in pre-Columbian Americas, and create astronomical calendars of breathtaking precision. The Aztec would construct Tenochtitlan, a city of 200,000 people built on a lake with floating gardens feeding a population larger than most European cities of that era. All of this, every pyramid, every codex, every carved monument, rested on the agricultural foundation laid by anonymous innovators in 8,000 BCE. The three sisters crops these early farmers developed would eventually feed an estimated 25 million people across Mesoamerica at the peak of pre-Columbian civilization. The impacts reached far beyond Mesoamerica. Maize would eventually spread throughout the Americas, becoming a staple crop from Canada to Chile. After 1492, it would spread globally, becoming the most widely grown grain crop on Earth, feeding billions of people across every inhabited continent. The agricultural techniques developed in ancient Mesoamerica,
Intercropping, sustainable soil management, adaptation to diverse microclimates are being rediscovered by modern agronomists seeking sustainable farming methods. The Three Sisters system is being reintroduced in regions seeking alternatives to industrial monoculture. But perhaps the deepest legacy is conceptual. These early farmers proved that humans could reshape their environment, create new plant varieties, engineer ecosystems to support larger populations, and fundamentally transform their own social organization. They demonstrated that human intelligence and ingenuity could alter the trajectory of biological and cultural evolution. Standing in 8000 BCE, no one could have imagined pyramid cities, or written books, or the global spread of their crops. They were simply solving immediate problems, finding reliable food, feeding their children, creating stable communities. But in solving these problems, they opened the door to human civilization itself. The agricultural revolution beginning in 8000 BCE Mesoamerica was quiet, gradual, unheralded, but it changed everything.